Before we delve into performance optimization, we need to understand a couple of concepts regarding the Flutter framework. We also need to understand what widgets, elements, and render objects are, and that we will explore in the next lecture. Please note that how Flutter renders its widgets to the screen is actually fairly complicated. Or maybe not complicated, but it will definitely take some time to fully understand and will require a significant time investment from your side if you really want to dig down on this. The aim of this section is not to go into great detail on how Flutter renders widgets, and instead we will focus rather on what we should be doing as Flutter developers to get the maximum performance from our animations and from our applications. So throughout this section, we will explore a number of different examples and take a more practical look at performance. However, with that said, there are a couple of things that we do need to understand about widgets, elements, and render objects to take full advantage of the Flutter framework and to ensure that we are running our code as optimally as we could. Because even though Flutter is fast by default, and in most situations we do not need to worry about performance, there are times when we can guide the framework to run in a more optimal way. And to do that, there are some concepts that we need to understand, and that is what we will explore in the next couple of lectures. So you may have already seen a graph like this, or at least something similar, and this is where we will start our performance journey, as we will need to understand the differences between these layers. So as you can see at the bottom, we have the engine, and this is where the low level operations are working. This is where we have Dart and Skia. And Skia is the graphics engine that is responsible for all of the painting. But for now, we will direct our attention to the Flutter framework and its respective layers. And as a quick summary, the important thing to understand about these layers is that each layer on top of another is a further abstraction, so a simplification, meaning that each layer on top of another basically makes it easier for us as developers to use the framework. So let's begin and take a look at the Dart UI layer. So to quote the documentation, the Dart UI library exposes the lowest level services that Flutter frameworks use to bootstrap applications, such as classes for driving the input, graphics text, layout, and rendering subsystems. So with that said, it is actually entirely possible to create an application using only the Dart UI library. But tread carefully, that will not be easy, as you will be responsible for everything. That will include laying out the application, painting, hit testing, etc. Possible to do, but not recommended. If we take a look at the classes that are exposed with the Dart UI library, you will see that a lot of them actually look very familiar. And we indirectly use the Dart UI library a lot in our code. So the Dart UI library comes directly from Dart, and the Flutter framework is basically built on top of that. Just makes it very easy for us to make applications without us having to worry about all of the complicated mathematics. And next up is the rendering layer. The rendering library is built on top of the Dart UI library and is responsible for taking our widgets and figuring out how they should be laid out and painted to the screen. This layer makes use of render boxes and render objects, which provide the methods to perform layout, painting, and hit testing, as an example. So if you've never heard about render objects and render boxes, then don't worry, we will explore them a lot more in upcoming lectures. The main thing to understand is that they are responsible for the final rendering of our application. Widgets that we as developers use actually do not manage the rendering at all. For each widget that we add in our application, the Flutter framework creates an associated render object, and that render object handles all of the complicated tasks of basically laying out the widget and painting it to the screen. As a Flutter developer, you may at some point find yourself needing to create a custom render object for a very specific component in an application. For example, maybe you need to build a very unique component and you need it to run as optimally as possible. Then instead of composing multiple widgets together to get the end effect, you can instead directly create the component using render objects. And some Flutter developers do this. However, for most developers and for most day-to-day situations, you won't find yourself even caring at all about what a render object is. And with that said, even though we might not be directly using them, we do need to understand why they are created and when they are created. Because the creation of a render object for a specific widget is expensive, and we want to minimize rebuilding these render objects, or I should rather say recreating these render objects. And the Flutter framework does try to do a good job managing the render objects, and it won't unnecessarily recreate them if it's not necessary. However, there are certain situations that we need to guide the framework to do this more optimally. So important to understand if we want to maximize the performance of our applications. The next layer in the tree is the widgets layer. So Flutter abstracts render objects by providing widgets, which are configurable UI components. So as Flutter developers, this is the layer that we will be most familiar with. Widgets, as we know, make it easy to perform layout, painting, and hit testing. For example, some layout widgets are column, row, center. Some painting widgets are text and image, and some hit testing widgets will be gesture detector and mouse region. For example, here is some code that shows you how you can center a text widget. Doing this using only render objects is a lot more complicated, and if you want to do this using only .ui, it will be even more complicated. So widgets allow us to easily create unique applications by composing multiple widgets together, and as we know, everything is a widget, or at least as Flutter developers, everything we care about is a widget. And then finally, at the very top, we have the material and cappuccino library, which is another abstraction so that we can easily style our widget to follow the material design specification or style widgets to look like iOS components. Some examples are floating action button and alert dialog from the material library. And just as we have the material library, we also have the cappuccino library. And there we have, for example, the cappuccino button and the cappuccino alert dialog. And these are just examples. There are many different material and cappuccino widgets. So instead of us having to customize our widgets to follow the material design specification, for example, we can instead just use these material widgets and easily incorporate that design into our application. So in the future, Flutter will probably support even more specifications, for example, OS X and Windows, and also the web. So as a summary for the entire Flutter framework, each layer builds on the last to finally make our lives as Flutter developers as easy as possible. This separation between the layers is also what allows Flutter to be fast, from both a development and performance perspective. The top two layers, so the material and cappuccino layer and the widgets layer, allows us to be effective developers, while the rendering layer does the heavy lifting to perform layout, painting, and hit testing, meaning we never have to be concerned about them, as long as there's a widget that does what we want to do. And also the framework does a very good job at being effective in only updating the components that need changing. Under most circumstances, we as developers will only work directly with widgets, and widgets do not manage rendering at all. The rendering layer manages that. So the framework is smart enough to only update the part of the screen that needs updating, and to do it efficiently to avoid unnecessary work. However, to get the best performance for our applications and animations, there are times where we will need to guide the framework to make the smartest decision. And these are the topics that we will explore throughout this section, as well as the tools that we can use to identify performance issues and how we can resolve and find those performance issues. Within the description for this lecture, there is additional resources that I highly recommend for anyone that wants to learn more regarding everything that we will cover in this section. Those resources are what made it possible for me to make this entire section. So I highly recommend them for anyone that wants to delve deeper into the topics that we will explore in the upcoming lectures.